Okay, we will continue from where we left out with. Okay, this is what I told you. There is a subnet mask which has to be defined. Okay, and here it indicates that here is the network portion, and this portion which is of 8 bit, which is totally right now it is 0, is for the host. Right now, obviously, if there is a network range of IP address, then there has to be a first IP address and there has to be a last IP address. The first IP address, let's see, will be of this network will be 172.18.7.0, okay, which is called as a network address, right? And the last IP address of the network, which is 172.18.7.255, is called as a broadcast IP of the network. Okay. Now, obviously, this figure will vary from 0 to 25. As I told, there are 256 values in each section of the 8-bit. Okay, that values varies from 0 to 25. That is what decimal system works like this way, right? Now, these two IP addresses, one is network and broadcast, obviously it is going to be used, but this IP addresses which we cannot assign to any host. Okay, it is for network and broadcast. So broadcast, will talk about what is the use of that broadcast IP address and what is the significance of it. Okay, but for the time being, just understand these two IP addresses which we cannot allocate to the any host, right? Now coming to this LAN, we need to allocate an IP addresses to this network. Okay, okay. Now there are 3 machines. Now we can allocate IP address starting from first IP, but obviously as I told, first IP address I cannot allocate. Then 172.18.7.1 I can allocate to this machine. Then next has to be allocated to this machine. Obviously there is a unique allocation has to be there. Then 7.3, right? So this is there. So in this way, whatever the devices are connected will be going like this way: 172.18.7.1, 2, 3, 4, and up to 255. But 255 we cannot allocate it, as I told. It is for broadcast. Then it will go up to 254, I would say. Now this LAN or a switch is connected to the some other device. Let's see, we are drawing it out here, and this device is connected to a switch as well, but here we are taking an example of router to understand actual router and how this traffic will move ahead, right? If you so let's see, I'm just drawing this router. Okay, this is what my router will be. Okay, this is the router symbol actually. Now here also, this interface where it is there, it has to be also allocated an IP addresses, this interface, right? So this interface I can allocate an IP address that is also in the range of my network only, 172.18.7. Okay, now remaining is for 4 to 255 which I cannot, I can say 254 which is there. Let's see, 254, right? So this is what my IP address allocation is, right? Now till here, this is called as a local area network, or this is what one range of LAN. Okay, because we have already designed logically that this network range has to be used, and this is a subnet mask. So the IP addresses which are within the networks will be able to form a LAN, will be able to allocate the machines, and then up to here, this is the boundary of local area network, right? Now this interface, which is 7.254, is can be an interface of your gateway. This is called as a gateway. Now gateway. Okay, if you cut this line, if you don't use this connection, and if this machines are connected using this IP addresses also, still these machines will be able to communicate to each other, using a switch. Okay, if they want to go outside the network, for example accessing the internet, then they'll have to go to the gateway, and so gateway is responsible to carry out their traffic to the outside network, as I have not shown in this case. So this router might be connected to some other networks where this link will go on, or this